Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The acidic strength of phenol depends on the stability of the phenoxide ion, C6H5O, formed after losing a proton. Electron withdrawing groups, EWG, stabilize the phenoxide ion by dispersing the negative charge, thereby increasing acidity. Electron donating groups, EDG, destabilize the phenoxide ion by increasing electron density on the oxygen, thereby decreasing acidity. Moving on to the next step. Identify the nature of each substituent. No 2-nitro group strong electron withdrawing group via both inductive and resonance effects. It stabilizes the phenoxide ion, increasing acidity. CN, cyano group electron withdrawing group via inductive and resonance effects. It stabilizes the phenoxide ion, increasing acidity. CH3, methyl group electron donating group via hyperconjugation and inductive effect plus I effect. It destabilizes the phenoxide ion by increasing electron density, decreasing acidity. CHO, aldehyde group electron withdrawing group via resonance and inductive effects. It stabilizes the phenoxide ion, increasing acidity. Moving on to the next step. Determine which substituent decreases acidic strength. Only CH3 is an electron-donating group. It donates electrons toward the ring and ultimately toward the oxygen of the phenoxide ion, making it harder for the oxygen to bear the negative charge, thus destabilizing the phenoxide ion and decreasing the acidic strength of phenol. And for the final step. Why other options fail? No 2-CN and CHO are all electron withdrawing groups that increase the stability of the phenoxide ion, thereby increasing, not decreasing, the acidic strength of phenol. Therefore, the correct answer is C. Therefore, the correct answer is option C.